don't know why that was there. I took a previous discussion and thing. The first statement is correct. I must have, okay, on we go. Okay, so I'm Jewish, I like to ask the question, why me?
Because you told me you know everything.
Yeah. Good point, Avner, good point. Okay, so I have a theory. How many, besides Jay, how many other people in this conference are here for the very first time? My theory isn't so strong. I figured the only reason I could be picked to discuss this paper was it's the first paper on the program. They were worried there were a lot of new people, and they wouldn't understand the norms of this conference. So they had me here to have a very short discussion, communicating quite clearly what the priorities are at this conference. But with only 5 new people, I don't know if that's the reason. So I'm kind of at a loss as to why I was picked to discuss this paper, being that it's a methodological econometric, as far as I'm concerned, an econometric contribution. And Jay, as you know, I'm a great fan of your papers, and I'm a fan of this one, but I will not be unable to provide any insight on the econometrics. So you're going to have to live with that fact. The time is up, yeah. I don't have much to say.
Now you will be viewed by 48,000 people.
48,000 people, I know. There is one thing I don't fully understand. So I'm gonna actually ask Jay, since I'm standing here, and let me talk about that. I'm not gonna. I've already said I'm not gonna be able to understand the econometrics. I would like to understand the intuition a bit better. So maybe you can help me out over there, and then I'll talk about the bigger picture, and then I'll be done in about 3 minutes. Okay. So you didn't emphasize this when you presented the paper, but a big part of this paper, when I read it, is there's a big difference between model uncertainty and estimation uncertainty, right? And in this profession, we don't really pay much attention to this in general, right? What I didn't understand, I tried a lot, but I could not figure out why, intuitively, why that makes a difference to the R squared. Intuitively, you would say to yourself, look, we have uncertainty, there's an epsilon term on the end. The R squared is basically measuring that epsilon term on the end. Why does it matter where that epsilon term comes from? And I'm going to actually ask you that question, Jay. I'll give you a few seconds before we go on. I will say this. So, when I don't understand something, what?
I didn't quite understand.
Okay, so my understanding when I read the paper is if I have a model that is in the population works, right? Perfectly, right? And I have a model which does not work in the population, the distribution of the R squared is different.
Oh, right.
I don't understand exactly why, because intuitively, I would say to myself, big deal. What does it matter where the uncertainty in the epsilon term comes from? Why does it matter whether or not there is whether or not the uncertainty has to do with the theory of the model working versus any other source of uncertainty? Yeah. I admit that the other sources of uncertainty are now going to have to think hard, like you don't actually observe returns. You're observing some returns with error. I don't even know what that means, but,
Yeah.
So
the thing is, when the model is perfect, the sample measure is always going to be lower than 1, because that's the way it is with sample measures. So it's not going to be, even asymptotically, the sample measure won't be distributed symmetrically around 1, because it can't be bigger than 1. And that's kind of the intuition of why something different happens in that case. And
I would have liked to, I think that is the one area I think this paper could be improved. If you could just, rather than just say, well, here are the statistics, my version didn't even have the appendix. I was going to email you and ask you for the appendix. I could look at the proofs. Then I thought, that's probably not going to be a very useful thing. But it'd be much better if I could look at this and say, if I was teaching students, I could say to the students, okay, here's the problem, and explain to them. And I can't do it. If you ask me, what I try to think about is I could definitely see why it matters, right? So, for example, in my size paper, right there, you can easily see how if the model specified or misspecified, it's going to make a very big difference, right? So imagine your CAPM, one factor CAPM works absolutely perfectly. So the beta estimates are perfect, right? And we've got a little epsilon in the end. Well, the epsilon in the end is just, the distribution of the epsilon has nothing to do with the risk premium. It's just random noise added. But now imagine you're in a different world where the beta estimates, okay, the model doesn't hold in population. So your beta estimate, so even if you get it perfectly, there's always going to be a piece of the risk premium the model doesn't capture, right? That's what I mean, doesn't hold perfectly. What does that mean? It means the epsilons in this case will explain risk premia. So in my case, they happen to be always negatively correlated with the size of the firm, right? Because the size of the firm also explains risk premium. So you can see why it matters whether or not the model holds in population and does not hold in population. But this is not what Jay's talking about. And so that's the one thing I would really try to understand at a more intuitive level rather than, there's an upper bound at 1 and that makes a difference. Maybe an example you could give a simple example where you could show how, okay, here it holds perfectly in population, we have a little bit of extra noise, this is what we see, here it doesn't hold, right? Here are the things, now look what I can do with these residuals or something like that. Okay, what is the big picture? There again, I think this is a great paper because I think we really nobody thinks about these things, right? And this is like first order. How do we ignore first order things? It'd be better, I think, you've got all the tables, this model does better than this model, and your personality is different to mine. If it was me, I'd like to take a stand. I would encourage you to take a bigger stand so people could take a bigger takeaway as to what does this say about the 7 models we have going for us. Does it?
I'm just interested in the truth. and if the truth is vague, then so be it.
Well, so you think you could say, well, it's like an R squared. There's 0 and there's 1 and there's something in the middle. I'd like to push you a little bit towards one of those boundaries. Otherwise, I worry that people take away from this picture, they read this paper and they get the takeaway that says, meh, there's nothing. Okay, fine. We have all these models, there's nothing we can really say about them. No. They're all, some does well in this situation, others do well in this situation.
No, that's not quite true. Pharma French and ICAPM, the Petkova version, especially the Petkova ICAPM, does well almost all the time. Pharma French is a little weaker, but they definitely stand out in comparison with the other models, so you can't take that away.
Okay. All right, I think that is my rather lame, I admit, discussion, which I don't fully take responsibility. I think oh, no, I made some notes when I was sitting there because things came up to me. One of the interesting things is, this happens a lot in corporate finance too, right? In corporate finance, there'll be a number of different, let's call them factors, whatever they call them in corporate finance, to explain the same effect. So it seems to me the methodology here could be just as easily applied to these corporate finance models, which people say, well, this is one effect, this is another, and maybe there we could get more clarity on the thing. And finally, just to reiterate the point you made, Pharma and French is optimized to explain those portfolios. So, to look at Pharma and French and look at those portfolios and say, victory for Pharma French. Okay.